And we'll move on with our program to Wolfgang Tremmel from DE-CIX, who will be talking about remote peering and some challenges related to that.
I'm Wolfgang, I'm working for DE-CIX. First time in Finland, first time at nog.fi. I'm a network engineer. I've been in this industry for quite some time. Started with companies who no longer exist, like Xlink, KPN Quest, via networks. Since 2006, I'm working for DE-CIX. The first 10 years, I was the manager of customer support. And since 2016, I'm running a thing called the DE-CIX Academy. And what I'm trying to do there, or what I'm doing there, is I develop trainings for customers. You can book me, you can hire me. I have a complete BGP training, and actually this came up as a question, and it very much relates to what I'm doing at BGP. So remote peering, why you want to do that? Because peering is usually keeping local traffic local, but DE-CIX does offer remote peering and at a number of sites. So why you might want to do that? You get peers you do not get at your home IXP. Also, you do not need to run your own connectivity or buy connectivity from a carrier to get it to a remote IXP. We simply deliver the remote peering LAN as a VLAN tagged on your DE-CIX port, and you can have as many remote peerings on your 1 or 2 DE-CIX port as you like. The connectivity is monitored and maintained by us, and you can also book the bandwidth you need via the DE-CIX portal, and that's enough of my sales pitch. If you want to really buy that, my colleague here is in the back, and you can talk to him. I'm not a sales guy, I'm an engineer. So let's have a look how remote peering can work and how we can utilize that for our network. So my example network here is, I'm based in Europe. I wrote this as being based in Frankfurt. So here, that's me, AS64500. This is me. I'm having 2 transit providers also connecting to them in Europe. Every sensible network should have at least 2 transit providers for redundancy. Also, I peer locally at DE-CIX in Frankfurt, and mind, this is an example. This works also for any other 2 IXPs or locations. Simply one remote, one a little bit further away. So, but I also peer remotely in New York, and in New York I have some peers. There are some US networks who peer in New York only, and there is here the green one. The green one is AS65501. That's the European network peering in Frankfurt and also remotely in New York. And by the way, do you know anything about these AS numbers? If you ever write a documentation or a presentation, these are AS numbers set aside for documentation purposes. Just a side note. Good. Let's talk about, this is a US network only. Let's talk about BGP announcements. You know, I'm announcing prefixes and I'm getting traffic for these prefixes. This is how BGP works. So here I'm announcing, this guy XAS65501 is announcing a /32 in IPv6. He announces that via DE-CIX. I get the announcement, but he also announces it via my 2 transit provider. I'm getting it via transit as well. And also I get his announcement via DE-CIX New York. So the same prefix, 3 announcement. Having a look at my BGP here, this is what I get. The one in bold print is the autonomous system path, and everybody who knows BGP knows that a shorter AS path is considered to be better. So we here have a long path via the transit provider, and we have 2 short paths via peering. So, but is it really better to get the prefix via DE-CIX New York in this case? No, that's not what you want. This is what we want. We want to exchange traffic locally in Frankfurt and not in New York. For backup, we consider transit because my transit provider also is Europe-based. So this is not what we want. So we have to get rid of this. And that's harder than you might think. Having a look at the BGP best path selection. So you might think, hey, we can use local preference for that. Local preference is at the very top of the best path selection. It's the sledgehammer of routing. So let's set local preference so to get an outcome we want to. So let's set local preference to 10 for my transit providers. Let's set local preference to 10,000 for DE-CIX. And let's set local preference to 5,000 for DE-CIX New York. So local preference, sledgehammer of routing. So the AS path length is now ignored. And we have this one here. That's how these prefixes are evaluated. So the best one is now via Frankfurt peering. The second best is still via New York peering. Like I said, that's not what we want. And the third one is via transit. So let's swap this. Let's set New York peering with 10. That should solve our problem. Should it? No. Because now we are getting all prefixes via our transit providers with a local preference of 5,000. And we get some prefixes with a local preference of 10 from New York. So what's happening now is New York prefixes are never even considered. So it's like I'm not ever appearing in New York. So still, this is never used here. So still, to say this doesn't work. So we still have our problem having peering in locally, having peering remotely, and wanting the transit provider for backup. So local preference doesn't work. What to do? We prefer local peers. It's always good to write down in words what we really want before we start configuring. We do not want to send traffic to local peers via a remote IXP. And we want to have our transit provider as backup if my local peering goes away. We do not want to have the remote peering as backup. How to solve that in a scalable way? We might think, oh, let's use MED. Reminder, the MED is by default only compared between the same next hop AS, but we can switch that off. MED by default is to signal your neighbor ASs which path you prefer. But if you can switch it off, you can say MED compare always. You can set MED yourself and use it as a kind of a second-rate local pref, so a parameter after the AS path. And to do that, we must set it everywhere. So let's have a look how MED would work. So we are setting local preference now 1000 everywhere, the same value. And we are having a look at MED. And like I said, that's after the AS path length. So setting MED of 50 to everything European and setting MED of 5000 to the US or to remote IXP. Now the MED comes into effect after the AS path length. So what happens? This is now what we get. The AS path length is evaluated first and then MED is evaluated. So still we have the remote peering on second place just to say this does not work. So what do we do? Let's read the documentation on IXP. We only want actually local providers to that remote IXP. That is what we want. And how can we do that? Well, this is now again DE-CIX specific. DE-CIX offers route servers. And there's a route server guide on our website, and we are using BGP communities to tag prefixes. And you can filter these communities by continent, country, metro area, and edge device. So, of course, be aware of the limitations. So that only works if the peer is connected via remote peering to that IXP as well. Because otherwise, how should we know where this guy is coming from? So we are using BGP communities which are attached to the prefixes by the DE-CIX route server. For example, in DE-CIX New York, we only want prefixes to the US. So we have a look at the communities and we only allow prefixes we receive from New York with that community attached. 63034, that's the AS number of the route server New York. Country-based origin, and the 840 stands for the USA. So with that, we get in New York only American prefixes. In Frankfurt, we only want local Frankfurt prefixes, for example, and we also can do that. And this is my solution, or one solution to only getting prefixes which are local to the remote IXP. So that takes care of sending traffic, receiving prefixes, sending traffic. So we have now solved 50% of our problem. But what about receiving traffic? We do not want to announce our prefixes to the remote peers. And again, peers only send traffic if they receive our prefixes. So what we need to do, we must instruct the route server to send our prefixes also only to peers which are local to that remote IXP. And again, this can be done via BGP communities, and there are so-called action communities for that. And this is all again documented on our website. The shortcut community here for this case is 65200, 65202. Just look it up, you don't have to remember that. That means announce my prefixes only to peers which are local to that IXP, not to remote peers. So, to summarize, how to configure remote peering for our New York example. Use the DE-CIX route server, announce your prefixes with communities tagged. Either you can use the traditional community or a large community here. We do no longer support extended communities. And only accept prefixes which are marked local for that IXP. And like I said, that example works for all of our internet exchange points. We are using not the same, but from the functionality, we have these communities everywhere. And basically you can filter what you want. You can say, I want US prefixes only, or for example, I want North American or South American prefixes, and so on. Let's go back to our network map. So what's happening? I'm announcing prefixes marked with the proper community. This is re-announced to local ISPs, to local participants. It is not re-announced to remote participants. The community and the route server takes care of that. And the other way, someone local at that IXP announces a prefix. The route server adds the community. We check that and we let it in. If someone connecting from remote announces a prefix, route server adds a community, we check it, and in this case, we do not let it in. So is that all? Well, there are a lot of networks who do not peer with the route server. What to do with them? What about direct peering? Well, recommendation here is Ask your peering partners where they're located, or have a look at PeeringDB. By the way, PeeringDB, one feature I think you did not mention, PeeringDB has a fantastic API you can use for automation. And peer with these who not peer with the route server only at their or your home internet exchange point. And that gives you a fantastic peering experience. And as always, you're using your transit provider as a backup if a peering point goes into maintenance or goes away. Another thing, if you download the PDF of that presentation, at the end there are some links, some RFCs, and some resources you might find interesting. And with that, thank you very much.